Hello dear friends, and welcome once more to another video in our YouTube channel. In this video, friends, shall be looking at the correction of the Cameroon Cgce 2021 Advanced Level Mathematics Paper 2. So friends, we shall be looking at the question along. We shall be providing so many hints and important tricks that students should take note when answering the paper 1 maths in general. So friends, stay tuned and make sure you watch the video from start to finish, guys, because at the end of this video, friends, after watching the video, you shall be able to answer all the questions that can come on similar areas like the one we tackle in this video. Thank you very much, friends, and for a quick reminder, if you're new to this channel, don't forget to hit that subscribe button looking at you so that you are going to have access to all our content, guys. And please, after subscribing, make sure you press the bell icon to get notified each time we upload new videos. Great. And friends, please don't fall for those who will use my name and create WhatsApp groups claiming to be Humble Mark, guys. They are not, okay? This is the Humble Mark talking to you on this video today. All my services are rendered for free, okay? I do not take money from anybody. Those who use my name and create WhatsApp group and they take money from students, guys, don't fall for them, okay? Those are criminals. So let's get started. Great. So friends, as you can see, the first question is saying that the polynomial f of x is defined by f of x equal to 3 minus ax plus bx squared minus x cubed when f of x is divided by x plus 2. The remainder is 45. Given that 3 minus x is a factor of f of x, find the value of the constant a and b. And the next part is saying that we should express 5x over x plus 3 into x minus 2 in partial fractions. Great. So friends, let's look at the first part. The first part is on polynomials. The first part wants us to find the values of a and b for which the polynomial 3 minus ax plus bx squared minus x cubed leaves a remainder of 45 when divided with x plus 2. Great. So friends, as you all know, let's have our polynomial of this form. So friends, as you all know, according to the remainder theorem, guys, if f of x leaves a remainder of 45 when divided with x plus 2, guys, it therefore means that f of negative 2, guys, has to be the same like 45, right? This negative 2, guys, was gotten by equating x plus 2 to 0. We have negative 2. That's, guys, according to the remainder theorem. Great. So friends, if we substitute negative 2 into all the x's in our polynomials and equate it to 45, guys, we are simply going to have f of negative 2 to be the same like 3 minus a into our x is negative 2 plus b into x, which is negative 2 squared minus negative 2 all that cubed, that is equal to 45. Great. So friends, if we simplify further, we are therefore going to have 3 plus, now guys, if we take negative a and multiply by negative 2, negative gives us positive. That's why we have 2a plus, now guys, negative 2 squared is 4, so that's why we have 4b. Then guys, negative 2 cubed is negative 8, but it's a negative in front, which turns out to be positive 8. That becomes that is equal to 45. Good. Then friends, if we add this 3 and 8, guys, we are going to have 11, right? Then if we carry it to the right hand side, we are going to have 45 minus 11, guys. So we are simply going to have 2a plus 4b equal to 34, because when you subtract 11 from 45, guys, we simply have 34. Great. So friends, this are simultaneous. This is one of the equations that we have. Keep in mind, guys, that we have been given two conditions, that x plus 2 leaves a remainder, or that when we divide f of x by x plus 2, it leaves a remainder of 45. Then that 3 minus x is a factor of f of x. Great. So we have been given two conditions and we have two unknowns, so we need to bring forth two simultaneous equations and solve for those unknowns. Great. So friend, this is the first equation that we have, but we see that we could still reduce this equation, right? We could reduce it again since we have a common factor of 2. Great. So if we divide all through by 2, friends, we expect to have a plus 2b, that is equal to 17. Great. So friends, we can call this our equation 1. Great. We have that as equation 1. So friends, now to use the next condition, if 3 minus x is a factor of f of x, guys, that therefore means that it leaves no remainder when divided by f of x. Great. That is very powerful, guys. That is what we're going to use to solve this problem. let's take note that if the equation tells you that it's a factor, that therefore means that it leaves no remainder when divided by 3 minus x. Great. Or better still, guys, the interpretation of this statement, it therefore means that f of 3 has to be equal to 0. That is, when you take 3 minus x and you equate that to 0, we are going to have f of 3 which is equal to 0. Great. So we come into our polynomial, guys, and we substitute all of the x's with 3 and equate it to 0. So we are definitely going to have f of 3 which is the same like 3 minus a, our x is 3, plus b into 3 squared minus 3 cubed equal to 0. Good. So we'll simplify further, guys. We are definitely going to have 3 minus 3a plus 9b minus 27 equal to 0, because 3 squared is 27. We have the negative. Then we have then 3 squared is 9. That's why we have 9b. Then minus a times 3, we have minus 3a. Good. So friends, if we simplify further, we are definitely going to have negative 3a. That is, if we take 3 minus 27, guys, which gives us negative 24. When it goes to the right hand side, it becomes positive 24. Then we have 9b minus 3a, that is equal to 24. Then, guys, there's something that can divide again. Something can divide. 3 can divide, right? 3 can divide, but we don't want to have a negative in front of the first variable. So we'll divide all through by negative 3. If we do so, guys, we are going to have a minus 3b, that is equal to negative 8. We can call this our equation 2. Great. So friends, all we need to do now is to solve for the values of a and b. We have equation 1 and we have equation 2. Great. So friends, in this case, we are going to solve by elimination method, right? So we are going to take equation 1 minus equation 2, guys. And the reason for doing so is that we want to eliminate a and solve for b. By so doing, guys, we are definitely going to have equation 1 minus equation 2, that is a plus 2b minus a minus 3b, guys. A and a, they will cancel. Then we are going to have 3b minus we are going to have 2b minus 3b. That gives us 5b. Great. So we are going to have 5b to be equal to 17 minus 8 gives us 25. That therefore implies if we divide all through by 5, we are going to have our b to be 5. Good. Therefore, guys, our b is 5. So, guys, if we simply substitute our b, equal to 5 in equation 1, we are definitely going to have a plus 2 into our b is 5 equal to 17, guys. If we simplify and solve for a, guys, we are going to have our a to be the same like 7. Great. So friends, these are the values of a and b that we were asked to find. So that's all about the first part. That's all about it. So friends, put in the comment section down below if there's something you're not understanding, and I'm going to explain in clear detail so that you understand so well. So friends, please don't forget to subscribe to the channel, and please like the video because it took me quite a lot of time to actually create this video for you guys. Thank you very much. So let's have our line and we tackle the next part. So friends, the next part wants us to express 5x over x plus 3 into x minus 2 in partial fractions. Wait. So friends, let's start by having the fraction as we have 5x over x plus 3 into x minus 2. So friends, I have a video where I showed you guys a way in which you can actually get this thing done in about 5 seconds. Yes, in about 5 seconds. So friends, make sure you check it out. Okay, it's called the cover-up method. Great. But in case of the exam, guys, for exam purposes, I'll recommend all of you to use the method I'm about to use to solve it now. Okay, and use it so that you're going to have all the marks, because the cover-up method, some of the methods that are very important to score the marks are not being illustrated. Okay, the cover-up method is used mostly to solve questions that involve MCQs where you don't have time. You have to do it very fast. Great. So friends, in this case, since all our factors we have here are linear factors, right? Friends, linear factors are simply factors in which the highest power of x is 1. Good. Okay, so the highest power of x down here is 1 and here is 1. Good. So all the factors we have are linear factors. So therefore express everything as a constant, that is a over the first factor, that is x plus 3, plus b all over x minus 2. Guys, what if what if one of our factors, let's say x squared plus 3, was a quadratic and an irreducible factor? We are going to have up but ax plus b. Okay, that's what we're going to have, ax plus b. Great. So friends, in this case now, to proceed further, we are going to multiply all through by the LCM. For instance, the LCM of x plus 3 and the x minus 2 is simply the product of x plus 3 and x minus 2. Great. So friends, if we do that so well, if we multiply by the LCM, guys, we are definitely going to have our a into x minus 2 plus b into x plus 3. That has to be identically equal to 5x. So friends, just for a quick comment, what if you notice so well, right? I have an identity sign here and not an equal to sign, right? Because most teachers I have seen, they always put but equal to signs here. Okay, maybe that's an error, guys. Maybe that's an error they always make. But friends, you're supposed to have but identities here. Okay, because this our statement is true for all values of x. Okay, all values of x, not some values. All values of x will make this our statement true, because an identity is true for all values of the unknown. An equation is true only for some values or just a particular value if it's a linear equation. Okay, good. So this has to be this equation has to take but an identity. Okay, an identity. Great. So friends, in this case now, all we need to do is to solve for a and b. By so doing, we can choose to solve for a, and in that case we have to eliminate b. Or guys, let's eliminate a. Okay, let's eliminate a. In this case, we are going to ask ourselves that how can we make a equal to 0? Great, x to be 2, right? Because if x becomes 2, we are going to have 2 minus 2, which is 0. 0 times a gives us 0. Great. So friends, we are going to let our x equal to 2. Okay, by so doing, if we put 2 into all the x's, this guy simply cancels. Okay, then 2 plus 3 gives us 5. So we are going to have 2, that's a into, we put in 2 here, we are going to have 2 minus 2 plus b into our x is 2, so it's going to be 2 plus 3, that is equal to 5 into our x is 2, so we are going to have 5 into 2. Simplifying, guys, simply gives us 5b equal to 10. Okay, because the term containing a goes to 0, then we are going to have 5b equal to 10. That therefore means if we divide all by 5, we are going to have our b to be 2. Great. So friend, that's the value of b. Okay, that's the value of b. So now to solve for a, guys, we simply eliminate b. Now we are going to put our x now to be -3, right? -3, because we are going to equate x plus 3 to 0 and solve. We have x to be -3. If we put -3 here, guys, we start with eliminate b and solve for a. Good. So when x becomes -3, we are now going to have a into x is -3, as we have here, plus b into x is -3, that is identically equal to 5 into -3. Good. So this way, guys, you see that we're going to have 0, right? B becomes eliminated, so we are left with a. That therefore means we're now going to have a into -3 minus 2, that is -5. Good. So we are going to have -5 equal to 5 times -3 gives us -15. Then dividing all by -5, guys, we're going to have our a to be 3. Oops, friends, here was supposed to be a. Okay, here was supposed to be a, friends, not b. Please just correct it. Here is supposed to be a. Good. So we have our a to be equal to 3. So friends, at this point in time, you scored all the marks already. Okay, you've scored all the marks. You're going to have all the marks. Don't bother, you're going to have all the marks. But to make your work a little bit shining, you can just come back and tell them that this your original fraction. Okay, that your 5x over x plus 3 into x minus 2 is identically equal to, you put in the values of a, you have your a is 3, you have it here, plus b, which is what, 2, identically equal to that. Great. So friends, that's it for the equation. That is it for this question. Okay, that is it. So let's go to the next question now. Awesome, guys, awesome, great. So now the next question, that's the question 2, is saying that given that the roots of the quadratic equation x squared plus 2k plus 2 times x plus 2k plus 5 equal to 0 are alpha and beta, find the values of the constant k for which alpha equal to beta. Then the b part, for k greater than 0, find the quadratic equation with integral coefficients whose roots are 2 alpha plus alpha beta plus 2 beta plus alpha beta. Then the next part wants us to find the range of values for which 2 minus x over x plus 1 is greater than or equal to 0. Great. So friends, let's start with the first part. This is so friends, the first part has given us a condition that alpha is equal to beta. So friends, if alpha equal to beta, guys, that therefore implies the roots of our equation are equal, right? Keep in mind that the roots are alpha and beta. If alpha is the same like beta, that therefore means that the two roots are the same, right? And friends, when the two roots are the same, guys, we obviously have the discriminant, that is b squared minus 4ac, that is equal to 0. Okay, this is now equal to 0 when the roots are the same. It therefore means that our b squared minus 4ac is greater than 0. Wait, keep in mind, friends, that our b in this case is given, our a in this case, friends, is given as what? 1, right? That's the coefficient of x squared. Our b is given as 2k plus 2, that is the coefficient of x. Then our c, which is the constant term, is given as 2k plus 5. We have it here. Okay, this is the quadratic equation. We have everything from the equation. Our c is 2k plus 5, guys. Don't make the mistake of saying that your c is 5. Okay, your c is the constant term, 2k plus 5. Then friends, if we plug in everything into this our formula, we are definitely going to have 2k plus 2 all that squared minus 4 into 2k plus 5. Since our a is 1, it leaves everything unchanged, that is equal to 0. Good. So friends, if we simplify everything so well, guys, we see that we can factor out a 4 for me, right? 4 can come out and cancel with this one. Then we simplify everything, guys. We are going to have k squared plus 2k plus 1 minus 2k minus 5 equal to 0. We see that there is a 2k and negative 2k, right? They can all cancel themselves. Then we have 1 minus 5, which gives us negative 4. It goes to the right answer, that becomes 4. So we are going to have k squared equal to 4. So when we solve, guys, we're going to have our k to be plus or minus 2. When we take the square, we are going to have k to be plus or minus 2. So friends, at this point in time, right, at this point, let me just give one other alternative that students could still use. You could send your 4 inside and have k squared minus 4 and use the difference of 2 squared formula. Okay, you still have the same answer. You still have your answer to be k to be either positive 2 or you have k to be negative 2. Good. But friends, the question has told us that we should find the values of k, right? Good. So this are the values of k. Good. Then the b part is saying that for k greater than 0, we should find a quadratic equation whose integral with integral coefficients 2 alpha plus alpha beta plus 2 beta plus alpha beta. Great. So friends, now for k greater than 0, that therefore implies we are going to have but 2 to be our answer. Okay, because 2 is greater than 0 and negative 2 is less than 0. Great. So we come back into this our quadratic equation, the one we have here now. We put the value of k to be 2. Put the value of k to be 2, friends. So this is the equation that we have. So for k equal to 2, right, this is our equation now up. Therefore becomes, putting the value of k to be 2, we are going to have x squared plus 6x plus 9. Because k becomes 2, we are going to have 2k, that's 2 times 2, which is 4. 4 plus 2 is 6, we have 6x. Then 2 times 2 is 4. 4 plus 5 gives us 9, that is equal to 0. Great. So friends, our alpha plus beta, that is our sum of roots, as you all know, it has the formula negative b over a, right? That therefore implies our a in this case is 1, b is 6, and our c is 9. Good. So friends, if we substitute everything, we're going to have negative, our b is 6, our a is 1, so we are going to have negative 6 over 1, that gives us negative 6. Good. Then our alpha beta now, that therefore turns out to be what? C over a, right? These are the formulas that we all know, guys. So our c in this case is 9, our a is 1, so that turns out to be 9. Good. So alpha beta is equal to 9. Good. So for now so now friends, our new sum of roots now, guys, our new sum of roots now is now going to be, so we simply come into where we have these guys, right, and replace this our and with a plus sign. Okay, because we are looking for the new sum of roots. Later on now we're going to replace this and with a multiplication sign. Good. So if we do that so well, guys, we're replacing the and with a plus sign, that is a plus sign in yellow that I have here. we are going to have we have 2 alpha plus alpha beta plus 2 beta plus alpha beta. Good. So now guys, but keep in mind that we don't know what is alpha, we don't know beta, right? We don't know those two things. So we may want to, at this point in time, we may want to collect the terms and make them similar. That is to make it similar into what we have, okay? Because we want to have alpha plus beta and alpha beta. We have alpha beta already. So if we add these two terms, guys, we are going to factor out a 2 from here. We are going to have 2 into this alpha, this beta. We have alpha plus beta, then we have alpha beta plus alpha beta. It gives us 2 alpha beta. But friends, what is alpha plus beta? We have it to be -6, right? And alpha beta to be 9. So if we plug that in, guys, we are going to have 2 into -6 plus 2 into 9. Simplifying that gives us our new sum of roots to be given as 6. Good. So guys, that's the answer we have. Then now we have to get our new product of roots, guys. Our new product of roots. As you all know, we are going to replace this our and with a multiplication sign. So we are multiplying the two terms. If we multiply out, guys, we are definitely going to have multiplying 2 alpha plus 2 beta gives us 4 alpha beta. Multiplying 2 alpha beta plus alpha beta gives us 2 alpha squared, guys. Doing the same thing, we are going to have 2 alpha beta squared plus alpha beta, all that squared. Great. But friends, we don't know what is alpha squared beta. We don't know what is beta squared alpha. Great. We don't know those things. So we have to arrange everything into the form that we know. So we are going to have 4 alpha beta into, at this point, guys, we are going to factor out 2 alpha beta. By factoring it out here, we are going to be left with alpha, and here we are going to be left with beta plus alpha beta, all that squared. We now have it in the form that we can easily simplify, right? That now is definitely because we know all the values of alpha beta and alpha plus beta. So if we substitute everything, guys, we are going to have 4 into alpha beta is 9 plus 2 into 9, alpha plus beta is -6 plus 9 squared. Great. So if we simplify so well, guys, we are going to have our answer to be 9. Okay, we have our answer to be 9. Great, we have it to be 9. So friends, now at this point now, guys, to get our equation, guys, we are now going to say that our equation, guys, is always of the form x squared minus the new sum of roots x plus product of roots equal to 0. Okay, that is the new product of roots as well, that is equal to 0. Good. So friends, that is the form in which our equation is going to take. Our new sum of roots, guys, we know it to be we know it from up here to be 6, and our new product of roots, we know it to be 9. Good. So friends, if we plug in everything, we are going to have our x squared minus 6 plus 9, that is equal to 0. Good. So friends, that is the equation in which we have. So friends, I'll highly urge all of you to please like this video. Please press the like button, so that is going to help others to locate our content, guys. I understand that so many students are praying for their advanced level GC exam, guys. Good luck to all of you as you prepare. Good luck. Please help me like the video, so that YouTube is going to help me to recommend it out to so many other people. And if you've not subscribed, guys, please don't forget to hit that subscribe button, so that you're going to have access to all our content. Thank you very much, guys. The next part now, guys, wants us to find the range of values of x for which 2 minus x over x plus 1 is greater than or equal to 0. Great. So guys, this is the inequality that we have. At this point, guys, we are going to start by getting all the critical values. Okay, we'll get the critical values by simply setting the numerator and denominator to 0. By so doing, guys, we are going to have x to be 2 and x to be -1. That is, if we set 2 minus x to 0, we solve, we'll have x to be 2, and setting x plus 1 to 0, we are going to have x to be -1. Good. At this point in time, guys, we can therefore draw a number line of this form. That is, we insert our calibrations. We have -1 at this point, we have 2 at this point. Great. So friends, you may want to calibrate only the points in which you need. Okay, to label only the points in which you need. You don't label the points you don't need. Okay, even if you label them, it is still good, but you're wasting your own time. Okay, good. And friends, since our inequality sign here is strict, right, so we are going to have a closed circle at this point. Okay, so at this point, right, we are going to have a closed circle, since since 2 is also part of our solutions, okay, because it's an equal to sign here. Then friends, this is where most students always make mistakes, okay. This is where they always falter. This is where most students make the mistake, guys. Under normal circumstance, where we have -1, why we are also supposed to have a closed circle. But friends, that is because -1 is not a member of the domain of our function, this function part, okay. So friends, in this case now we are going to have but an open circle, not a closed circle. The reason for doing so is that x equal to -1 is not a solution to this our problem, because if x becomes -1, guys, the bottom here is going to be 0, right, and the function becomes undefined. So we are going to have an open circle here, not a closed circle, not a closed circle. Take note, guys, take note, take note. Keep in mind that the solution to this our problem must be what? Members of the domain of this our function, okay. They must be members of the domain. Good. So friends, if we pick any number between -1 to negative infinitive, and from -1 to 2, and from 2 to positive infinitive, let's take the easiest number, guys. Let's take 0. We notice that 0 is found between -1 and 2, right? If we take 0 and we plug in 0 into this our original inequality, we are going to have 2 minus 0, that is 2, all over 0 plus 1, which is what? 2 over 1, which is 2, and 2 is positive, right? Keep in mind, friends, we are interested in what? The positive value. So we are going to have a positive in this range, we are going to have what? A positive solution, because everything in this range is positive. And friends, once here is positive, at this point, guys, must be negative, okay. Here must be negative, and this other way we must also have what? A negative. So everything here is negative, everything is positive, negative. Then friends, which region are we interested in now? Keep in mind that our inequality here is what? A greater than or equal to. So we need those regions that have given us what? Positive signs, and it's from -1 to 2. So our range now, guys, is now going to be from -1 less than x less than or equal to 2, guys. Don't make the mistake of putting less than or equal to where you have -1, because -1 is not part of the values we are going to take, okay. It is not even part of the domain of this function. So we are going to have but strict less than sign here. Great. So friends, thank you very much for watching the video, friends. Thank you so much. I really appreciate. And friends, don't forget to subscribe to the channel if you've not done so. Please press the like button, guys. That goes a long way to motivate me to keep producing more great content for you, friends. Thank you very much, and good luck for your exam, guys. As soon as this video ends, we are going to upload that for question 3 and question 4. Thank you very much, friends, and see you in the next video. Stay safe, and good luck as you prepare for your exams.